we will begin talking about inferential statistics. Before we were talking about descriptive statistics, which summarizes data. Now we're going to use that data to make generalizations or conclusions about populations. Suppose we wanted to estimate the proportion of blue M&Ms in a very large bowl. How might we go about estimating this proportion? We could count every single M&M in the bowl and then separate the blues, but that would be very time consuming. And generally speaking, you don't want to spend too much time with your population if you do not have to. So instead, we can take a sample of M&Ms. So we really want to make sure that that sample is random and large enough. When we take a sample, we're able to get the sample proportion of blue M&Ms. And there we can draw a conclusion about the entire population of M&Ms. So that sample proportion of M&Ms is called a point estimate. A point estimate is a single number, a statistic based on sample data that is used to estimate a population characteristic. It is not always to the population characteristic due to sampling variation. So we can't generally say for sure that point estimates will give an accurate and exact estimation of the population, but it would be pretty close. Let's go through an example. The paper U.S. College Students' Internet Use, Race, Gender, and Digital Divides reports the results of 7,421 students at 40 colleges and universities. The sample was selected in such a way that it is representative of the population of college students. So, that sample is large and that sample is random. The authors want to estimate the proportion of college students who spend more than 3 hours a day on the internet. So they were able to see that 2,998 out of the 7,421 students reported using the internet more than 3 hours per day. So that is a sample proportion of 40%. So this sample proportion is considered a point estimate because it is an estimate from sample data about the population. So they would generalize that about 40% of all college students use more than 3 hours a day on the internet. Here's another example. The paper, The Impact of Internet and Television Use on the Reading Habits and Practices of College Students, investigates the reading habits of college students. The following observations represent the number of hours spent on academic reading in 1 week by 20 college students. So they have this sample data, and we can find several point estimates out of this. One of them is the sample mean. If they were to find the sample mean, they would see that the average college student reads about 14 hours per week spends 14 hours a week on their academic reading. They could also find the sample median, and they'll find that the median, the 50th percentile, is around 13.75 hours per week. So again, these are two examples of point estimates, estimations that you gather from a sample to generalize about a population. All of these are considered statistics. So you try to choose a statistic for computing an estimate, and sometimes it could be what is considered unbiased and biased. So the definition of unbiased is that the point estimate is equal to the true value of the population. So if we were to estimate our population characteristic, we would have an unbiased statistic here and an unbiased statistic here. This one would be considered biased because it is not in the center, the true value is not in the center of this sample data, of the sampling distribution. In most cases, we will be working with biased statistics simply because it is really hard to 100% conclude that a statistic is the exact true value of a population characteristic. But here's how we can work with that. If we choose a statistic that is unbiased, that means that it is very accurate. But what you want to do is choose an unbiased statistic that has a small standard deviation for a sampling distribution. So typically speaking, you want a large sample, okay? A large sample gives you a smaller standard deviation. This doesn't mean that you should always pursue a large sample over other means of statistics. It just helps you understand exactly how point estimates work. So small standard deviation as well as an unbiased statistic.